In this lesson, we're going to look at our understanding of formulae. This is the first example of 5 examples. In this example, we're going to look at the formula for the circumference of a circle. The circumference C equals pi multiplied by the diameter of the circle D. C equals pi times D. What we want to know is what is the effect on the circumference C if we double the diameter D? Well, if we double the diameter D, that means we can write down our formula again. C equals pi times, and if we are doubling the diameter, that's like 2D. So what we have now is C equals pi times 2D. What that means is pi times 2 times D. We know that it doesn't matter which order we multiply in, so that's just the same as C equals 2 times pi D. What we have on this line is exactly the same as the top line, except it has been multiplied by 2. That means our answer for C will also be multiplied by 2. So if we double the diameter D, then our answer for C will also be doubled. Our question was, what is the effect on C if we double D? Well, the effect is that C is also doubled. Example number 2. In this example, we are going to look at the formula for the area of a circle. The area A equals pi multiplied by the radius squared. The question this time is, what is the effect on the area A if we double the radius r? Now, in the previous example, when we had C equals pi times D, when we doubled the diameter, the effect was it just doubled the circumference. We'll have a look to see what happens this time. So, what is the effect on A if we double r? So, doubling r means we in effect have 2r instead of r. So, A equals pi times, and instead of just r we have 2r, and we know that the r part is being squared, so this time it's 2r that's being squared. Okay, so what we have now is A equals pi times 2r squared. That means that A equals pi times, and then 2 squared is 2 times 2, which is 4, and r squared on the end. So now we have A equals pi times 4 times r squared. Remembering that it doesn't matter which order we multiply, that means A equals 4 times pi r squared. So in this line, what we have is the exact same as the top line, our initial formula, only it has been multiplied by 4. So if we double r, the effect is that the area A is multiplied by 4. And that's our answer. This is example number 3. This time we're going to look at our formula for working out the speed. So speed equals distance divided by time. Average speed equals distance travelled divided by the time taken. Our question this time is, what is the effect on speed s if the time t is halved. Okay, so this time we're going to half t the time. So that means s equals d over a half t. So we have s equals d over a half t. But what does that mean? Well, the half down here is confusing things slightly. So what we want to do is get rid of this. If we multiply the bottom of the fraction by 2, then a fraction here, 1/2, will disappear. If we multiply the bottom of our fraction by 2, then in order to keep the fraction at the same value, we must multiply the top by the same number. That means we have an equivalent fraction. So s equals d times 2, which is 2d, over a half t times 2. Multiplying by 2 here just makes the fraction disappear, the half disappear, which leaves us with t on the bottom. Our question asked us what was the effect on s if t is halved. So what we want at the end is we want something similar to our top line d over t, but then we want to know what it is multiplied by so that we know the effect on s. So how do we separate the d over t part from the 2? Well, s equals 2d over t. That actually just means s equals 2 times d over t. Now if you're wondering, well, how does that work? Where does the 2 come from? Well, if you think 2 is just a whole number, to make it simpler, if we think of it as 2 over 1, then 2 times d in the top gives us a 2d on the previous line, and 1 times t on the bottom just gives us our t part. So that's where this whole number 2 over 1 comes from. We can forget about the over 1 part again because we know that that just is the same as 2. So what we have now is exactly the same as the top line, only it is being multiplied by 2. So what is the effect on s if t is halved? Well, if we halve t, then the speed is multiplied by 2. And if you think about it, that makes sense. If you're traveling a given distance, then if you want to do it in half the time, half t, then obviously you must be going twice the speed. So s is multiplied by 2. That's our final answer.